Okay, I'm delighted to be joined now by Charlotte Hughes. She's marketing scientific content writer from Hamilton Process Analytics. Just a bit of background about Hamilton. Their technology, process analytical technology, is a suite of tools designed to monitor and control critical process parameters in real time. So, by integrating advanced sensors, software, and automation, PAT provides invaluable insights into complex bioprocesses such as cultivated meat production and fermentation. Charlotte, welcome to Protein Production Technology International.
Thank you, Nick. Thank you for having me today.
Now, just quickly before we get all technical, could you give me a brief overview of your journey into food tech? How have you ended up at Hamilton?
Sure. Really, for the past 10 years previous to me working at Hamilton, I spent it working as a researcher. So I was mostly focused on protein biochemistry, characterization and structural studies of different proteins. And I guess towards the final 2 years, so about after doing like 8 years worth of lab-based research, I started to think about what I actually really enjoyed. And what I enjoyed was, believe it or not, actually deep diving into a lot of research and the articles and understanding, the background information, kind of going down a bit of a rabbit hole. And so then I started to look towards transitioning into scientific writing.
Mm,
And I did this for a year and a half in the university world, and then an opportunity came up at Hamilton, and then this is kind of where I am at the moment. So I've fallen into the protein, alternative protein space, shall we say, based on working at Hamilton and being able to really deep dive into the research that's out there at the moment. Yeah.
mhm. So cultivated meat, it's one pillar of several pillars of alternative proteins. Now,
Yep.
cultivated meat production involves several critical steps. Could you break down the typical process into its key stages and highlight where your process analytical technology can be most impactful in addressing the challenges and optimizing yields?
Sure. So I would say that when we consider the whole process, then we are looking from the very beginning. So, say water prep and media prep. And within this stage, you can start to really think about critical process parameters such as pH and conductivity, and remembering the importance of the fact that, for example, pH is a really important parameter to control during cell culture. So it's important to get it right at this step before it goes through the remaining steps where you're going to be introducing your cells.
Mhm,
And then as we start to move into these processes where we have these cells, and for example, proliferation, as we're starting to move up the bioreactor scales in different volumes, to be able to get higher volumes and higher yields of these cells. Um, Within this as well, you can start to look at not just the standard ubiquitous type of pH and and DO, but also carbon dioxide, as well as these as the cell density starts to increase and we're starting to get this accumulation of carbon dioxide. We can also start to monitor additional like key process indicators such as cell densities, such as viable cell density or total cell density. And this is very important. And we can again use these same parameters as we start to go down like differentiation as well.
mhm.
So yeah, lots of different stages I would say that our parameters can be observed.
Mhm. Now, given the complexity of cell culture, pinpointing the most critical process parameters is essential. So, what specific parameters do you believe have the greatest impact on cell growth and product quality, and how can your technology help us monitor and control these in real time?
Mm. So I would say, as I said before, like pH is definitely, it's like the fairly standard, bog standard, like parameter to monitor. Small
Mm,
changes in pH can cause huge problems for cell metabolism, and this is obviously going to be a huge issue when it comes to things like cell viability, for example. Um, DO as well, because these cells, mammalian cells, are usually aerobically respiring, and so of course they require sufficient oxygen for them to be able to do this. Um, and then I guess the other one that I would also say and highlight is carbon dioxide, based again because of the fact that they are aerobically respiring. This creates an issue whereby if there's too many cells within the culture medium, then carbon dioxide starts to accumulate. This can be a problem because the cells themselves are in an environment where potentially there is insufficient, say, dissolved oxygen that's also dissolving within the media itself, because there's this limitation of how much gases can be dissolved within the media itself. In addition to this, carbon dioxide is also a acidic gas, which means that as it starts to dissolve, this is going to change the pH of the environment. And then, as I said before, pH is really, is a crucial thing to be monitoring all the time. So I would say they're the crucial things to be looking for.
Now, it's clear that PAT plays a vital role in both upstream and downstream processes. Could you elaborate potentially on the specific PAT tools and applications that are best suited for each stage?
Sure. So within upstream, most of the time we're tending to look at steps or stages of production that are before cell harvesting. So as you're starting to go through the proliferation stages, and also differentiation stages as well. So for this, then you would need parameters that are, monitoring cell cell viability, cell health. So you standard like pH and DO and carbon dioxide, but then in addition to this, because you're monitoring to ensure that your cells are healthy and happy, well, I won't say happy, but viable, then you would obviously want a viable cell density sensor and on some way to be monitoring it. So yeah, that would be something to be definitely making sure that you are monitoring. When it comes to downstream process, at least from my understanding, the majority of the time this is after you've done cell harvesting, and so it's when there is a final cell product, and then potentially, for example, the way that I would consider it would be, we've got your products, and then you want to put it into a packaging.
Mhm.
And one thing that you could also monitor at this stage would be, for example, oxygen, to trace oxygen amounts, because it's known that once meat starts to oxidize, it doesn't quite have the curb appeal, shall we say, as what a fresh product will look like. It starts to discolor, the flavor could be affected. And so you would want to ensure that the oxygen is basically not present or very minimal within this area.
So loads to consider.
Yeah.
As we transition from R&D to commercial production, so these are your customers we're talking about. New hurdles inevitably arise. So how does your technology adapt to the increasing scale and complexity of that process? I would imagine that you're
Mhm.
working with customers along that scale ruler, as it were.
Yeah, exactly. So that's the thing. A lot of customers, I think, are at essentially that stage of going from R&D and trying to transition into this commercial scale, if not doing so already. And so by doing this, what happens is they will need a system for PATs, which means that it's able to be transferable across the scales. And one way to do this is, it's been demonstrated in many studies that PAT itself, especially with sensors, and we're looking at, say, CO2, DO, pH, and also viable cell density. These types of measurements are very much transferable with different scales, and so that's something that's always useful for our customers.
Hmm. Making sense of vast amounts of processed data is crucial as well for optimization. So how does your system integrate data from different stages, and what insights can we expect to gain from that comprehensive
Mhm.
data set?
Sure. So the sensors that Hamilton tend to produce are inline sensors. And so because they are inline sensors, this means that they are collecting direct measurements within the process itself. And by doing so, it means that they can collect real-time data as things are happening. And when you integrate this into a specific type of control system, so for example, at Hamilton, we do offer what we call intelligent arc sensors. And so these sensors themselves, they have an integrated transmitter. By having an integrated transmitter within the sensor itself, it means that there's 2 points. One is the measurement data is stored directly onto the sensor. And in addition to this, it's able to monitor its health status continuously. So then this creates some form of like double data collection, as it were. And then when it's connected to the Arc software, so this is an additional tool whereby data transfers over, and then the customers can start to collect data. And by using this system, it's cataloging and logging all the time. The data that you collected at different stages of production. And so, this can be used as a way for the customers to then be able to go back to their data and have a look at and see exactly what happened at a certain point. Yeah.
So that's what your technology does, and that's some of the benefits for the customers. Let's talk about some of the challenges for the cultivated meat sector. Generally, we could be here all day. Scaling up, obviously, cell culture for cultivated meat is incredibly complex. Now, what specific hurdles do you see in making these processes reliable and consistent, and how can your technologies help fine-tune cell growth conditions, and what insights can it provide to help media formulations?
Sure. So, with scaling, I think it's a very multifaceted type of situation. There's lots of things that are involved within scaling. So you mentioned media, that's one of them. Media costs, some of the ingredients, they can be very costly just by themselves in small volumes when they're doing R&D. And so to be able to scale it to a much larger volume, that's going to be incredibly costly for the customer themselves. And so yes, being able to actually test or monitor cells as a kind of this can be used so for example, like different parameters can be used to monitor or test cell growth and viability within different media compositions. So this is the way that that could be used.
Talk about some of the challenges facing the cultivated meat sector generally now, and we could be here all day. Now, scaling up cell culture for cultivated meat is incredibly complex. What specific hurdles do you see, Charlotte, in making these processes reliable and consistent?
hmm So within scaling and making sure that the products are consistent, changes as we go from different volumes of cell culture, and that can have a huge impact. So, for example, as I mentioned before, like carbon dioxide accumulation, this can have an effect on the cell metabolism. And so by having effects on cell metabolism, then this can also then have an effect on the actual cells themselves, which remember, we cultivated meats, the cells are going to be the products themselves in the end. And so we want to ensure that the cells are produced in a reliable and consistent way. And with PATs, then this can happen because the aim of PATs is to ensure that certain parameters are within a specific range or limit,
Mhm.
and this is to tailor it towards an ideal final end product's quality status, as it were. And so by ensuring that these parameters are within a specific limit, then it means that our final products should be as we expect.
Mhm. Now, integrating your technologies with bioreactors was also crucial for optimal cell culture. So, what challenges have you encountered in this area?
hmm Um, I would say that with integrating into different systems, so there's obviously lots of different bioreactor systems, and so being able to ensure that sensor products are able to go into these different bioreactor systems is crucial. I will say that Hamilton do offer a very comprehensive portfolio of obviously different parameters, but also with different connectivity options. And
Mhm.
so this is one way that Hamilton are helping or trying to ensure that they are able to cater to different customer needs. In addition to this, we do have the ARC system, and the ARC system is Hamilton's own connectivity. So it's their intelligent connectivity system, and as part of it, there's also ARC converters as well that are offered. So if a company is using a specific connectivity system, then we can use a converter to be able to ensure that these new ARC sensors are able to be used. And the advantage of using them is that, as I said before, like the data collection is twofold, so both on the sensor itself and also on the software itself, and also because it's has this intelligent capabilities, it means that there's a potential for continuous control as well. Yeah.
We'll talk about regulations in a second. Obviously, that's another big challenge for cell-cultivated meat producers. But building consumer trust is also essential for the success of cultivated meat. So how can technology assure product safety and quality? I guess we're interested here in leveraging automation and data transparency to address those potential consumer concerns.
Yeah, so I would say that for customers, what they would like to see to know is that the product is basically safe.
Mhm.
I would say, and then secondly, that when it comes to gaining their trust, that secondly, once they know that a product's safe, that it's also really tasty because
Mhm.
it's a consumable product. And one way to do this is basically ensuring that the product itself is of a standardized quality. And with PAT, you can do this. So by, as I said previously, monitoring specific parameters that affects the end product quality,
Mhm.
then we can start to ensure that all the way through production, that basically the final end quality is going to be guaranteed.
Mhm.
Yeah.
And another roadblock is obviously price parity with conventional meat. So how can optimization or process optimization help us reduce production costs?
So I guess there's really maybe a couple of ways, I would say. One would be that because one of the main drivers of expense is the media, based
Mhm.
on ingredient costs, also volumes that are going to be used, then one thing one strategy really is to try and reduce the amount of media that's been used if it is going to be very expensive. So, for example, using advanced bioreactor systems, such as like perfusion systems, is one way that could be done. And we know that ensuring that within a certain, really the aim is that within a certain volume of media, the maximum amount of cells are going to be produced. And by doing checks of critical process parameters that we know are going to influence essentially cell viability, and also being able to monitor the proportion of viable cells that we have in our total yields, that's going to be an important thing to help.
Now, in terms of the regulations, that environment, the regulatory environment for cultivated meat is constantly evolving. So, what are the biggest challenges, in your opinion, for companies facing this landscape, navigating this landscape?
Mm-hmm. As you said, because the regulations are always changing, because these are novel foods, it means that it's in a way uncharted territory. And so because
Mhm.
of this, it can create some form of, I wouldn't say confusion, but uncertainty. And so because this, one way to, I guess, combat it is essentially collecting as much data as possible.
Mhm.
So collecting as much data as possible at each step, um, across different variables. And I don't just mean across different parameters within the system itself, but also, for example, ensuring that your protocols, your methodology, your equipment is functioning, that it's in peak performance, shall we say.
Mhm.
This is going to help as well. So in trying to ensure like all these different parts it's going to is one of the important issues, I would say.
Mhm. And not only is it uncharted territory, it's
Mhm.
also quite rigorous,
Yes.
submitting a dossier. So how can Hamilton's PAT data contribute to building a robust and compelling dossier for cultivated meat products, whether that's with FDA or EFSA, EC, or
Hmm.
Singapore?
Yeah. So I would say that, as I said, it's creating is the most comprehensive data set that you could possibly do.
Hmm.
So this could include, um, for example, collecting information across the different stages of production, ensuring that the equipment itself is functional. And so,
Hmm.
for example, with like arc sensors, we are able to do this whole sensor health status monitoring. So it once that's been recorded, then we can ensure that can be submitted as part of the dossier to indicate that the measurements that were corrected were of, say, true values or correct values because the sensor health was at optimum performance, as it were,
Hmm.
if this makes
Are you able
sense.
to? Yeah, definitely. Are you able to share any examples of how PAT has been utilised in other industries to meet stringent regulatory requirements?
Hmm. I mean, I would say the biggest example is probably biopharma.
Hmm.
Um, it's although it's a process whereby you're using cells to produce the different products rather than in cultivated meats, the cells themselves are going to be the products. Um, the regulatory process and the requirements that are needed for the products that are produced by biopharma, because again they're going to be in some way not necessarily consumed, but they're intended for human use, as it were.
Hmm.
So this, I would say, would be a prime example because, yeah, PAT technology has been used um, for many years, I would say, and we have many customers that are from biopharma as well.
Now we're going to talk now about how PAT applies to cultivated meat production as the industry progresses to more complex meat structures. Now, maintaining tissue integrity becomes increasingly challenging as we do that. So, how can PAT help monitor and control parameters affecting tissue formation and structure?
Hmm. So all I would say would probably be, as the products themselves start to become more complex, you are going to more than likely have several different types of uh, cell types within a single tissue. So, for
Hmm.
example, muscle or fats, etc. Um, and PAT can be used as a way of ensuring that the products themselves have the expected proportion, shall we say, of different cell types within them. So I guess this like meat to fat ratio in a way. In addition to this, then we can start to ensure as well that the cells that are actually within the final products are actually viable and living, because when we um, have these end products to be able to sell them, we would want to ensure that the products are actually of a good quality before they actually go to retail. Um,
So,
yeah.
PAT can differentiate between those cell types and monitor their interactions. Is that what you're saying?
So, for example, Insight that we have, which is a capacitance measurement probe. The measurement principle itself is it's been shown to be able to differentiate between different cell types
Hmm.
based on the capacitance measurements that you have. And so, based on this, then um, it's hypothesized that it could be used as a way, as a tool for you to be able to, you know, um, basically see proportions and understand that you've got the correct proportions of whatever cell types that you would want within that specific like products.
Yeah. So presumably with that information, you can then optimize the co-culture process.
Yeah,
Um,
exactly. Yeah.
Now, developing suitable extracellular matrices is crucial for complex meat structures. So, how can PAT be used to characterize and optimize matrix properties?
Hmm. Well, the way that I would think about it would be, I guess, two parts. So one, how these ECM components are actually affecting the cell viability. So whether they are compatible with the cells and actually encouraging them to basically be able to proliferate and mature onto the actual scaffold itself. Using, for example, capacitance probes, because this can be done. And the other one, I guess, could also be used as a way of monitoring different other parameters. So, for example, whether or not these components affect, for example, pH within this, cold culture environment.
Mm-hmm. Have you actually had any cultivated meat products yet, Charlotte?
No.
You tasted them? No, me neither.
No.
So
Have
we're in the
you?
same. I haven't, no, but I understand that achieving the desired texture, flavour, and appearance requires precise control over all of the parameters that you've discussed. So how does Pat provide insights into the relationship between process conditions and sensory attributes?
Mm-hmm. So the way that I would think about it is these cells are going to be intended to be consumed, and usually within everyday kind of cellular metabolism, they produce specific compounds, and all these types of different compounds within themselves, within the cells themselves, are going to contribute towards some form of flavor profile. And so it could be that you would intend on ensuring that your cells are at a particular healthy growth, as it were. That's going to try and fuel this flavor profile that you want.
Okay,
Yeah.
we're going to talk now about how other subsectors of alternative proteins might be able to aid cell cultivated meat. This space, or the alternative protein space, is rapidly evolving. So how can cultivated meat benefit from advances in other, plant-based or fermentation-derived proteins?
Mm-hmm. I mean, to be honest, I thought they could benefit quite well. I mean, they're all part of this alternative protein space, so it's a way of acting collaboratively and, good, like a community of going forward together type of situation.
Mhm.
I mean, there are products out there that are not necessarily alternative protein spaces, but I mean, in most supermarkets these days, you can buy, for example, like conventional meats and plant-based products hybrids.
Mhm.
So this is like an everyday example, I would guess, of how this alternative protein spaces could move. There's also been products that have been released earlier this year, for example, Good Meat 3, I think it's called, the one that's 3% cultivated food and then 97% plant-based products as well. So this is a good example, I say, this having this collaborative spirit. And then not only this, when we start to think of, I guess, the consumer, although they would want something nice and tasty and cost not so costly, shall we say? I wouldn't say cheap, but like cost parity type of situation.
Mhm.
I guess the good thing about this is that we can start to also consider the nutritional value of these products. And so, for example, if we have a situation where products from, say, precision fermentation, where like vitamins have been produced, these vitamins could then be used within cultivated meat to try and fortify these products. A
Mhm.
bit like how everyday breakfast cereal is fortified with vitamins, we could do something similar with like cultivated meat, and this could help to create some nice collaborative work together.
You wouldn't have thought that 3% cultivated meat in a product would that make that much difference, but
No,
obviously,
no,
obviously it
yeah,
does. And on that note as well, we also saw recently that Lidl is introducing a 60/40 range of meat
yes.
that's 60% conventional beef and 40% pea protein, I think it is. So
Yeah,
yeah.
something like that, yeah.
Yeah. Now we've already discussed some of the common challenges, such as regulatory hurdles and cost reductions. How do you think the different subsectors could collaborate in terms of shared solutions to accelerate industry growth?
Mhm. Um, I mean, I think some of the industries are, I wouldn't say old, but maybe slightly more established in their
Mhm,
works than cultivated meat. So, for example, biomass fermentation for the production of, say, like corn products. I don't know if I
mhm.
can say the name,
Yeah,
but yeah, but like corn products.
I'm not going to
They've
stop you.
yeah, like they've gone through they've gone through the regulatory process, and so they know what's necessary. And being able to share that information, I think, between the different alternative protein industries would be useful.
Mhm. Funnily enough, you're actually in the same edition as Marlow Ingredients, so obviously they're the parent company of Corn.
Okay.
So you're going to be in good company. Now, just a couple of questions left, Charlotte. As the market expands, the alternative protein market expands, consumer perceptions are going to evolve as well. So, how do you think collaboration between the various subsectors could shape consumer attitudes towards cultivated meat and create a more sort of favourable environment for the industry?
hmm I mean, I'll be honest, I think we've seen little glimpses, maybe, hopefully, with what's happened with the vegan or completely plant-based, meat or protein alternatives. More than 5 years ago, if anyone said to you that they was going to be eating like a vegan product, most people be like, why? But nowadays it's very common. It's probably more. It's just as common as getting like conventional meats. Um, and so I think by especially doing this collaborative joining, like for example with the cultivated meat and plant-based meat products, it's a good introductory product for the consumer to be able to try it,
Mhm,
know, and familiarize with it before going ahead with buying more. And once people start to familiarize um, and associate it with being like the everyday inverted commas normal, quote unquote, that's going to help, I would say.
mhm. And there's lots of research and surveys that indicates that the majority of people are quite willing to try cultivated meat. So
Yeah, exactly.
uh,
Yeah.
we're not all naysayers. Now, I've just got one final question for you, Charlotte. Given the
Mhm.
the rapid rise of innovation in this particular sector, where do you see Hamilton's technology heading in the next sort of 5-10 years? Do you envision Pat evolving to meet the next level of challenges and opportunities in the sector?
So I would say that yes, Pat's always going to keep evolving, especially at Hamilton. I mean, Hamilton was born on the innovation of its founder. And I would also say that the application support teams that work very closely from Hamilton with the cultivated meat um, industry, they are very supportive and they understand and communicate very well with this industry. And so probably I would say that, through this communication, understanding what the community's needs are as well is going to help to drive further advancements and further technological innovations as well.
Mhm. Well, I can't wait for all of that. Charlotte, it's been wonderful talking with you. I'm not sure if you know yet, but we'll be meeting up again on the 30th of October for the webinar that is sponsored
Ah,
by Hamilton.
okay.
And a little birdie tells me that you will be on that panel. So I'm not sure if you've been told that yet, but you
Yeah,
will be.
yeah, I know. Yes, I have been told that. I got told this
Good,
week.
good. Well, we'll meet again, and we'll probably go into a lot more detail, and we'll have some producers and
Mhm.
some research institutes on that panel as well. So we'll go into a lot more detail. But thank you very much for your time. It's been lovely talking with you, and I
Yes,
hope to
thank
see you
you.
soon.